Welcome to this video. This is a short presentation basically to derive the solution to a quadratic equation. Most of us are familiar with this equation that x is equal to minus b plus and minus square root of b squared minus 4ac over 2a, but a lot of us have never been presented with the derivation or have forgotten it. So you can look at this as a little revision, and it's one of my pet subjects to go back to the basics in algebra. So here it goes. We start with our quadratic equation ax squared plus bx plus c equals 0, where a, b, and c are numeric constants. Obviously, a is non-zero, because if a was 0, we wouldn't have a quadratic equation. This means that we can divide both sides of this equation by a, which gives us this equation. So x squared, and this coefficient becomes b over a, and the c term turns to c over a. Now we do a little trick, which I've shown here. I've added a term b squared over 4a squared, and I've taken away a term b squared minus 4a squared. Means this is not going to affect our equation. We've added the same quantity and taken it away. And if you note, this quantity is the square of half this coefficient. So it's the square of the coefficient of x in this equation. Some of you may be familiar with the term completing the square. This is basically what we are doing here. Now, if we look at the first three terms of this equation, which I've highlighted in red, the first three terms are basically x plus b over 2a to the power 2. Because if I have x plus b over 2a to the power 2, I'll get x squared plus 2x times b over a over 2. The 2's cancel, and then I will have a term b squared plus 4a squared. Now, moving on from this equation, we do a little algebra. We move these two terms to the right-hand side. We change the sign, or for want of a better word, we take away these two quantities from both sides. Effectively, it means every time we move a term from one side of the equation to the other side, we keep it as is, the sign changes. So minus b squared over 4a squared becomes just b squared over 4a squared, and c over a becomes minus c over a. And now we see that the common denominator between these two fractions is 4a squared, and if I get the common denominator, I will end up with this expression. And we're beginning to see that this very much looks like what we're looking to obtain. Now, this expression on the left is a full square. So if I get a square root from both sides of the equation, I will get x plus b over 2a on the left-hand side, and the right-hand side will be plus and minus the square root of the quantity under the radical sign. We can see that the term 4a squared, being a complete square, can come out of the radical sign, and that would be as a single term on the denominator, and the numerator remains the same. Now, if we move the term b over 2a to the right-hand side, we get x is equal to minus b over 2a plus and minus square root of b squared minus 4ac over 2a. Now, if we notice that we have the same denominator here, and we can write that as one fraction, as x is equal to minus b plus and minus b squared minus 4ac over 2a, which is what we aimed to prove. I hope you liked this video. Please click on the subscribe button if you liked it, and hopefully I will see you in another video very soon.